Hi everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder why it is so hard to get people to believe in important science stuff like climate change or wearing masks? Well, this new study dives into exactly that. It turns out that just giving people a really clear explanation doesn't automatically make them believe it, especially when that science touches on their political beliefs. You know how sometimes when you are trying to convince someone of something, you give them all the facts, all the reasons, all the evidence. You are hoping they'll really think it through, right? The big idea in this paper is that we often assume that giving people mechanistic explanations that show how things work, like how greenhouse gases trap heat or how masks stop germs, will make them engaged and thinking deeply. It is like a step-by-step guide for their brain. But what if that assumption is wrong? What if people don't always process these explanations so logically? This study wanted to see if these supposedly clear explanations actually make people think deeply about the science, or if they fall back on other ways of thinking, especially when the science is tied to their identity or politics. So, the researchers decided to test this with a bunch of people, over 500 folks from the US. They split them into groups and showed them explanations about two hot topics: climate change and mask. Wearing to stop viruses. They created two versions of these explanations for each topic. One version was what they called coherent, meaning it was accurate and made sense logically. The other was incoherent, meaning it had sneaky logical flaws, like saying that when the sun's rays are sent aloft sooner, it makes the earth warmer. It is meant to sound plausible, but it is actually flawed. They figured if people were really thinking deeply about the science, they'd spot the flaws in the second version. And here is where it gets really interesting. When they looked at how people rated the strength of these arguments, they didn't see much difference between the coherent and incoherent explanations. This is a big clue. If people were thinking hard about the logic, they should have rated the flawed ones as weaker. The researchers tried another way to see if people were thinking critically. They asked people to list their thoughts after reading the explanations. They specifically looked to see if anyone noticed the flaws in the incoherent explanations. And guess what? Only about 5% of the people who saw the flawed explanations actually pointed out a problem. That is a tiny number. Another thing they looked for was whether people were actually focusing their thoughts on the explanatory mechanism itself, the how and why of the science. Only about 14% of participants did this. So, what were the other people doing? The study found that many participants fell into other categories. About 17% engaged in what they call grandstanding. This means they were expressing their opinions, signaling their group identity, or even talking about conspiracies rather than engaging with the science itself. Things like scientists are always wrong these days, or masks are stupid. On the flip side, there were also concerned grandstanders saying things like, we need to stop putting carbon dioxide into the atmosphere. This shows strong feelings about the topic, but it is not necessarily engagement with the specific scientific explanation offered. Then there were those who gave simpler reactions like listing adjectives: annoying, unnecessary, bad, or emotions. Concerned, hopeful, or just words related to the topic: germs, vaccine, mask. These suggest some thought, but not deep processing of the mechanism. And sadly, the biggest group, about 35%, really didn't engage at all. They said they had no thoughts or wrote irrelevant things or just nonsense. So, what is the big takeaway from all this? It's that simply providing a clear, mechanistic explanation, which we often assume should lead to better understanding and acceptance, doesn't automatically work. People don't always engage with it objectively and systematically. This study really highlights that just because someone is engaged with an issue, meaning they have strong feelings or opinions about it, doesn't mean they're actually engaging with the scientific explanation itself. Their engagement might be driven by their identity, their beliefs, or their group affiliation. It seems like the presence of an explanation itself, even a flawed one, can sometimes make people feel like they understand the issue without them actually diving deep into the causal logic. It is like having a recipe for a cake. You might see it and think, I get how cake is made, without actually understanding the chemistry of baking. The study also looked at individual differences. They found that people with higher science literacy were a bit more likely to focus on the mechanism and even spot flaws. But even then, higher science literacy didn't guarantee they'd rate the explanation's strength accurately. And the personal relevance of the topic, how much it affects someone personally, was a much bigger driver of how they responded than the quality of the explanation. Now, like any study, this one has its limits. They used pretty short explanations, only 35 words. Maybe longer explanations would have led to more deep thinking. Also, they didn't directly measure if people actually learned something, or if their attitudes changed. They were looking more at how people process the information. So, what does this mean for us and for science communicators? It means we can't just present the facts and expect people to accept them, especially on highly politicized topics. topics, people aren't just blank slates absorbing information. They bring their beliefs, their identities, and their political leanings to the table. This research suggests that to really get through, science communication needs to think beyond just providing information. We need to consider what motivates people, how their identities are tied to certain beliefs, and create situations where people actually want to think deeply and reflectively. It is not just about supplying the what, but also understanding the why behind people's responses. This is a really important reminder that human thinking is complex, and sometimes our desire to be right or to fit in with our group can override our ability to process information logically, even when that information is about science. It makes you wonder all sorts of things about how we consume information today. What do you guys think? Have you ever found yourself leaning on your gut feeling or what your friends believe rather than digging into the facts? Let me know your thoughts in the comments below. And if you found this breakdown helpful, please give this video a thumbs up and subscribe to RUBIN'S Mind Lab for more deep dives into fascinating research.